So I made this little contraption to look at the total uncertainty of a digital manifold gauge, and I just wanted to get an idea of, if we measured pressure and we measured temperature and we looked at superheat or subcooling, how accurate would the gauge really be. So what I did here is, coming out of the TXV, we actually have what's called saturated liquid, right? It goes through the TXV, it flashes, part of the gas flashes off as flash gas, and we have this mixture that's about 70% liquid and 30% vapor. And then what I did is I ran that line through here, and I just put a piece of copper here where I could mount my temperature probes on here, and then measure pressure right at the same location. So what I'm looking at is a true picture of saturation temperature under actual working conditions, so I can get an idea of what's going on. Now I got a sight glass over here, and I put the sight glass just so we can visually see that liquid in there. Let me zoom on that so you can see that. You can see it's boiling inside there, and that boiling liquid is at the saturation temperature. So if we take a look at our gauges right here, we can see that, let me get this where we can read it nicely. You can see we got T1 and T2, and they're both running right about the same. I'm going to scroll through the menus once. They're within 0.2 of a degree of each other. Okay, so we got two different probes that are within 0.2 of a degree, and you can see my pressure, 79.5, 79.3. They're running almost dead together within a few tenths of each other. Now if we scroll through the menus here, you can see I got 1.5 degrees of superheat. Now we know that refrigerant's actually saturated. It's not superheated at this point. It's saturated, so it's a mix. So what we're looking at is the total uncertainty, because there's uncertainty in the pressure, there's uncertainty in the temperature, and we're looking at the total uncertainty between those two measurements, because we know for a fact it's pure R22 in the system. We know the saturation temperature corresponds to pressure, and what we're looking at here is, the difference between them. So it goes to show you how accurate the gauge really is. If we look at our temperature, 48.4, and our measured temp, right, that's the difference the meter's calculating. So I'm flipping back and forth there. So it's 47.1, 48.4, 1.3 degrees difference. Subcooling, we're not measuring any subcooling because obviously subcooling is below the saturation temperature, and we're probably still slightly above the saturation temperature on both sides, so that's why there's no subcooling calculation. But that just goes to show you, overall, these meters are typically within 1 to 2 degrees on superheat, and so you can be pretty confident in your calculations.